All right, this video is about debouncing and deglitching. Now, uh, a lot of um, internet schematics are missing a deglitching capacitor. They give you a schematic and only certain people put them in. Here's one up here. And they show it from the positive of the IC, which would be like, say, pin 14 or 16, to ground. But that's not really true. That ground should actually be down here, right across the chip. You put deglitching capacitors in after you wire your circuit up. Okay, you add them in from plus to ground. Here's what they look like. They're 104 as a number, which means if you convert it, 0.1 microfarads. Okay? And what do? I'll explain to you what they do. Unlike other videos that tell you nonsense and worthless information, this can bite you in the ass like you can't believe. Now, here's a picture of a diagram of an IC, and it's a quad flip-flop. It's got a series of flip-flops in here. Now, every time one of these flip-flops flips, okay, it puts a glitch out on the power line. It pulls voltage from the VCC, I think it's called. It's been a long time. Anyway, from the positive, all right, you got your ground on the chip, and you got your plus VCC. Every time one of these flips, a little tiny spike is formed at the power. All right, now how long is this wire? We don't know. Okay, well, what happens is when voltage goes through wire, it creates a magnetic field. Then when it shuts off, you get a collapsing field, which gives you even more voltage. Well, you flip one of these, and then a millisecond later you flip one of these. Well, that glitch is ringing. Okay, that little glitch you formed is ringing, and it can get in this guy 1 millisecond later, or whatever, microseconds, whatever it is, and he'll flip back, and you'll be pulling your head out. Now, where I first encountered this was Popular Electronics had a digital thermometer, my famous digital thermometer. I've told you stories about it. And as it's counting up, as the temperature's changing, I don't think I ever saw any even numbers or odd numbers. Well, anyway, it would never land on an odd number or even number. I forget what it was, and I couldn't figure it out. And you go over the wire and over the wire, and that's because the guy never put any deglitching caps across the 7490 chips. A 7490 chip is a counter chip. It's a divide by 2, it's a divide by 5. Put them together, you got to divide by 10. It's a dirty bird. It creates a lot of little spikes, which become little ringing glitches. Now, we won't call them bypass. Some people say, that's a bypass cap. Let's call it a deglitching cap, because that's what we really want to understand. We want to understand glitches. Where did they come from? Well, sometimes it's a case of you run too thin a wire. Okay, now in this case, I had trouble with the Huff and Puff. I use very fine bus wire, and all my deglitching caps go to the positive of the chip and to ground. But what you really need to do, what I found is even these chips, you really need the deglitching cap from the positive to the ground of the chip, right along the back. There's a space in here, usually in an IC, in the back. Lay it right in there. I can't show you the ones I did do, but there's deglitching caps here. But just a difference of 1/8 inch made a big difference, okay? And I was chasing my tail. But the 7490s on this thermometer, they wouldn't give me an even number. So you see the thermometer, the temperature was either even all the time or odd. And what I did was I traced it back to what is going on inside the 7490, and I realized that it's a series of flip-flops in the 7490 were flipping, that this condition would happen. And it was either an odd number or even number when it happened. And it stuck in my head, and I put a 0.1 across it, and it fixed it. And originally the engineer in RCA, Kenny, he says, something's wrong with your power supply. He says, probably your power supply is ringing. Well, it was worse than that. And I had bought this book at the same time, Don Lancaster. Yeah, I'm in Lancaster, PA. We call it Lancaster. This has information about deglitching. Okay, that's where I first read it, and I'm like, son of a bitch. And I went back and I started fixing projects. All right. Now I also want to tell you about debouncing. Anytime you use a mechanical switch, here's what it looks like in slow motion. You ready? Put the switch on. Bang, bang, bang. Okay? Usually about 3 times. And you're like, no way. Yes. Mechanical switches, they bounce. When they close, they go bang, bang, bang. And those get counted. Okay? And you can put a pull-up resistor on that switch and you'll still get bounce. And what you have to do is you have to change your software to allow for the a delay of key bouncing on your keypads. Okay, you fix it in software nowadays. In the old days, look at the TTL cookbook or look up debouncing. You'll see circuits using gates, and there's some real fancy ones. They use like a 7414 chip, but all mechanical switches bounce. Now I'm going to tell you there's 2 exceptions because there's ones that don't bounce. Yeah, there are. A mercury switch that's wetted, the electrodes have to be wetted. They don't bounce. Every time a mercury switch goes on and off, and it has wetted contacts. How I know this? I worked in a mercury switch company. All right, they don't bounce. And then there's a Hall detector switches that were used on high-speed keyboards, used in retail. They have a little magnet in each key, and as it goes down, there's an IC there that's got a Hall detector in there. And as the switch goes down, it goes high. And when you let the switch power up, the magnet comes past the Hall detector and it switches it again, and there is no bounce. And you can find these Hall detectors inside a fan for a computer. You take it apart, there's a magnet in there that's a piece of flexible magnet. It goes in there as a loop, and then it looks like a transistor in there, and that's a Hall detector. And when you first turn the fan on, if it's in a certain position on the magnet, it puts the current on it, it makes the fan flip, and then it unflips, positive, negative, and the fan starts to spin up. Okay, really cool project. Take a PC fan apart, a 12-volt one. Okay, don't take apart a 120. Hey, there's no Hall detector in here. I could just see them now. Okay, but in life, when anybody tells you, watch out for this, watch out for that. Now, I worked with a guy, and one day I was explaining to him about glitches and deglitching capacitors. And you'll get odd counts on your shift registers, your divide by 10, dividing chains will go screwy. You might not notice it, depending on what the circuit is. You might not notice that your dividing chains are not dividing correctly, they're glitching. But it depends on what the operation is, okay? And the faster you run an IC chip towards the brink of disaster, the more likely it's going to glitch. And it might only happen twice a day. It's just the right conditions, and you'll pull your hair out. And that's all because you left. And some of these guys that draw better schematics, they're sitting in there. Okay? That's what that capacitor does. And that capacitor really should be drawn across the chip. Because if you put that on the ground and it's a 1/4 inch away, you develop a glitch. All right? And it'll drive you nuts. And that's what my problem was with one of my Huff and Puffs. I put the chips to ground very close to the IC, but it wasn't good enough. It needs to be right across the IC because I'm running these 74HC chips at a much higher frequency than I ever ran anything before. Okay? And I just said, let me step in there, make a video about glitches and where they come from. Remember, anytime you put voltage through a wire, okay, you develop a magnetic field. Okay, and a nice piece of wire like this, I see a lot of people on the internet, they use these, this is like a cat wire, cat 5 wire, and they got these things that like 1 foot long, and the whole thing's a freaking mess, and they show you that the circuit works, and but this, anytime you put a current through a wire, or a piece of wire, or a short piece of wire, a magnetic field is built up around that wire, and when you shut it back off, a higher voltage is created as the magnetic field collapses. Okay? Read up on it. It's all sitting there, but boy, when you are going crazy with glitches, okay, they're a little hard to track down sometimes. And we used to get circuit boards in for repair. And we had people that were handicapped, mentally ill people that put them away, and they'd stack them, and they'd break these little capacitors that are across the ICs. And that board would work, sort of. And you'd be in there for hours troubleshooting. And then you look and you see there's capacitors missing. They got broke off by the people, the mentally ill people that stacked them. And they were told 100 times not to stack them. But that's the way that was. But we had this one tech, the boss had him copy. We bought a tester from a company, and he had his boy, let's call him his boy, and his boy wired the thing up. And they finally came to me and they said, we're stepping through sequences, and we're getting double steps and triple steps, only at certain points. I knew right away, deglitching caps. So I went in there, and I found they had the schematic for something, and they were copying it. That's illegal. They were copying it. And the guy saw all the deglitching caps down at the bottom of the schematic, all in parallel. That's how they do it sometimes. The deglitching caps will be on the bottom part of the schematic as like they're a separate circuit, but what they're trying to do is they're trying to tell you on IC5 you have a 0.01 across it, or a 0.1, and they take them down and put them in a separate part is because it makes the schematic cleaner for you to diagnose. Okay, the more parts you can remove from a schematic, the easier it is to follow. And this guy, I looked over at his side, he had a big bundle of capacitors all wired in parallel. And this was this boss's boy. Thought the guy was so smart, and I'm standing there, I'm going, what the hell is that? Well, that's on the schematic. I'm like, no, that's not what. And I tried to explain to him, and the two of them were looking at me like I was crazy. I said, look, add some capacitors to these chips here, the counter chips, and it fixed it. But they didn't come to me and told me to fix it, because they were pissed that I showed them up. But they called me in and said, we're having this problem. I knew right away it was deglitching, because I had gone through that with that stupid thermometer. See, that's why I tell you, the more things you build, and you get yourself into a mess, and you dig yourself out. Like I said, the thermistor I was coating with epoxy. 15 years later, whatever, it hit me. It told me to coat the thermistor with rubber cement. And the guy never said, don't use epoxy. Just coat the thermistor so the water won't hurt it. Well, when you coat a thermistor with epoxy, it can't expand and contract with temperature. So you get a nonlinearity. Well, this is the stuff that when you have hands-on experience and you sit through it and you think it through and you do a lot of reading and you find the problem, that's how you learn. Now, I watched Shango, and someone sent them a radio repair, and Shango went through it, and the guy had unsoldered a couple parts, and then he put them back in the wrong place. And Shango took the radio and he fixed it for him. I wouldn't have done that. I'd say to the guy, follow the schematic step by step, pin by pin, and you'll find it. Okay? Anytime you fix something for someone, after 3 days, they fixed it in their head. Okay? That's how the human brain works. Oh, I got that one. Yeah, I got it. Meanwhile, Shango got it. And that's the things that get my crow, as they say, is all the times I fixed something for someone that they couldn't fix, and then later on when they tell the story, it was they or them that fixed the thing, and it was actually me. And that's the stuff that got my crow. And a lot of people will say to me, you shouldn't let that bother you. It bothers me. I'm telling you straight out, right? But don't forget, mechanical switches bounce. And that gets fixed in the software on modern stuff. On older electronics, if you're dealing with old TTL chips, all that, you got to go look at debounce circuits. All right? And the exception to the rule is those hole detector switches. And you can get a hole sensor inside of a fan motor for a computer, a 12-volt fan. That's cool in itself, getting one of those out. And there's two kinds of those. One, when you put the magnet near it, it switches on. Pull the magnet away, it switches off. And then there's one where you got to give it the north to turn it on and the south to turn it off. That's cool stuff. I'm telling you right now, there's an experiment in itself to play around with. Taking an old fan apart on a computer. Also, to get it apart, you peel the label off, and underneath there's a little a plastic Jesus clip. You can take a fan apart for a computer and re-oil it and use motor oil from a car. Do not use 3-in-1. And you could also use sewing machine oil. I always rebuilt my motors for my computers. Whenever they get slower, they would stop. I think that's it. All right, that's it.